Welcome back, geometers. This is Mr. Klinkerman again. This is part 2 of the notes for section 1.4. Remember, you ought to be taking notes on these lessons. You ought to be writing down questions that you have so that when you get to class, you don't forget what it was that you were wanting to know about angle measures in this case. Now, if you recall, we already focused on lesson 1 that you will be able to measure, name, and classify angles. And so, we're moving on a little bit right now. And we're going to talk about how you can use the angle addition postulate to find unknown angle measures. Angle addition postulate, one of those two postulates you wrote down in your assignment for us the other night. Okay, now the angle addition postulate is, of course, for doing addition with angle measures. I want to specify the measure part of that. You only add angle measures together. And it turns out that it is very similar to the segment addition postulate that you guys have learned previous to now. And so what I'd like to do is to take a moment and remind you of what the segment addition postulate is. Recall that with the segment addition postulate, what you would do is you would have one point that was between two other points, so that they were all collinear, of course. And in this case, the point that's between the two other points is point Z. It's between R and S. And if you have a point between two other points, you can find the measure of the longest segment by finding the sum of the measures of the two shorter segments. Or in other words, RS, okay, this is mistyped right here, excuse me. That should be RS is equal to RZ plus ZS. That's the segment addition postulate. Well, when we're talking about angles, you don't put a point between two other points, but what you could do is you could have put a point in the interior of an angle. And I want to show you really quickly what I mean by the interior of an angle. Look at angle ABC, and I'm going to go ahead and highlight the interior of the angle. The interior of the angle is just simply the portion of the angle that's between or within the two sides of the angle, the sides being ray BA and ray BC. Now the angle addition postulate is based on placing a point in the interior of an angle, and that could be this point right here, point P. Now, if I put point P in the interior of the angle, and then I draw a ray through it, what happens is that there are three angles now that are created. The first angle is the one that we started off with originally, angle ABC, with sides BA and BC. The second angle, I'm going to highlight the interior of the angle for you, is angle ABP, right here. And then the third angle that you've created is this angle PBC. Right there. Now, just as with the segment addition postulate, what's going to happen is that when we add the measures of the two smaller angles together, it's going to give you the sum of the largest angle. By the way, those are all called adjacent angles because they each share a common vertex and a common side. Alright, at any rate, look at this equation right here. The measure of angle ABC, the large angle, equals the measure of angle ABP plus the measure of angle PBC, right there. Right. Two smaller angles added together give you the measure of the larger angle. Great. Let's look at an example. Alright, in this example, I'm telling you that the measure of angle HOT represented as it's the angle that has the sides OH and ray OT right there. That angle has a measure of 84 degrees. So if I were to draw all the way from one side of the angle to the other side of the angle. Let me extend that side of the angle a little bit. That's an 84-degree angle. Then I'm telling you that the measure of angle DOT, this angle right here, has a measure of 42 degrees. So let me label that. That's 42 degrees from here over to there. And what we're going to do with that is we're going to find the measure of angle DOH. Well, quite simply, we're going to use the angle addition postulate to be able to make this happen. And I imagine you could do this without this equation, but I need you to get used to writing this equation nevertheless for when it's a little tougher with variables and so forth. We know that the measure of angle HOT has to equal the sum of the measures of angle DOH and angle DOT. Now if I use substitution then, that means I can say that 84 equals the measure of angle DOH plus 42. And then I can use a little simple algebra. I can subtract 42 from both sides. 84 minus 42 is 42. And that tells me that 42 degrees is the measure of angle DOH. Alright, now if you know one of the smaller angles and the largest angle in this picture, then you just simply use subtraction to find the measure of the other smaller angle right here. This is 42 degrees as well, it turned out. Now I want you to notice something about this particular picture, just for notation purposes. Turned out that the measure of angle DOH is equal to the measure of angle DOT, as you see right there. And whenever two angles have the same measure, we say that those angles are congruent to one another. So we can say then that the measure, not the measure, excuse me, I need to return to the previous slide. We can say then that angle DOH is congruent to angle DOT. Alright, last thing to observe. Whenever I was talking about the angle measures right here, I used an equal sign to say that those measures were equal. Angle measures can be equal to one another. But when I was referring to the names of the angles, this part right here where I have it highlighted, you're going to notice I use the congruent symbol. If ever you're saying that two things are congruent, you say that the figures themselves are congruent. You don't say that their measures are congruent. Alright, small detail, emphasize that plenty more within class. Let's move on to a tougher example. Alright, again in this picture, I've got a situation where I've got two smaller angles whose measures are going to add up to be equal to the measure of a larger angle. And what I've told you is that the measure of angle MAR, the largest angle, is 124 degrees. So from here all the way across is 124 degrees. Alright, now what we're going to have to do then is we're going to have to use an equation, first of all, to find the value of x. That's what I'm telling you to do. And we can simply use a relationship that the measure of angle MAR equals the measure of angle MAC plus the measure of angle CAR. Or in other words, we can say that 124 is equal to 6x minus 11. Let me erase some other things here so this is a little easier to write. Plus 4x minus 25. A little more erasure here and we'll have this. Alright, well that equation there is going to help us find out what the value of x is. We'll start with collecting our like terms on the right side of the equation. 6x plus 4x is going to give you 10x. Minus 11 minus 25 will give you minus 36. Add 36 to both sides. And then divide by 10 and you'll get that 16 is equal to x. Alright, not that difficult, just using the angle addition postulate. Now we're going to continue with a few more parts to this same question. The next thing that I want us to do with this picture is I want us to find the measure of angle MAC and the measure of angle CAR. All right, there's the measure of angle MAC, and here's angle CAR. Now the good news for us is that we've already found out what the value of x is, and it turns out that the value of x is going to be key to finding out what those two smaller angle measures are. Whenever we try to find the measure of angle MAC, we can just say that the measure of angle MAC is equal to 6x minus 11, but since we know that x is equal to 16 from the previous slide, we can say that it equals 6 times 16 minus 11, which is equal to 96 minus 11, which is equal to 85. Alright, so 85 degrees. Oh, hold on. .85 degrees is the measure of angle MAC. Now to find the measure of angle CAR, we're simply going to substitute 16 in place of x and add expression 4x minus 25. So the measure of angle C is going to equal 4 times 16 minus 25, which is equal to 64 minus 25, and that's 39 degrees. Right, so 39 degrees from here to here. And the last thing I want to make sure that you're aware of is that if we add those two measures together, 85 plus 39 is equal to 124. And that's how you can check your answers, simply by adding them up, seeing that they give you the original measurement that was given to you. Alright, if you have questions or anything, you should pause and possibly rewind to see how these last couple of examples have worked. I'm going to give you another example to try on your own next. So let's get to that. Pause the video, see if you can find the measure of angle SPG and the measure of angle YPG, which, by the way, is going to require you to find the value of x first. Go ahead and try it. Hopefully you've got your answer at this point. You can see where I've written the angle addition postulate equation, where I'm saying that the measure of the larger angle, SPY, equals the sum of the two smaller angle measures, and I just substituted 90, 3x plus 2, and 2x plus 37 respectively into that equation. It's because the 90 was all the way from here to here. By the way, it means you can put that little box in the corner of that angle, doesn't it? Alright, and then you end up with 90 is equal to 5x plus 39, and then 51 is equal to 5x, and so 10.2 is equal to x. Not the friendliest of numbers. Hey, that's fine. Why do we need a friendly number anyway? Haha, I tell you what, if you see what's going on, I actually made a little mistake, didn't I? That was supposed to be a minus 2 right there, which means that this should be a 35, and then 90 minus 35 is 55. Alright, there's a nicer number for us. X is actually equal to 11. Okay, now once we have found the value of x, then you can go ahead and find the measures of angles SPG and YPG. The measure of angle SPG would be 3 times 11 minus 2, which is 33 minus 2, or 31 degrees. And then the measure of angle GPY is going to equal 2 times 11 plus 37, or 22 plus 37, 59 degrees. And then just to check our answer, 31 plus 59 is equal to 90, so our answer checks out. Good job if you got 31 degrees and 59 degrees for your answers. Alright, we got one more concept to talk about. Let's move on. And that concept is the one of angle bisectors. You're going to recall that the other day in class we did a construction. with our protractor, with our compass. And what we did was we learned how to bisect an angle. And that meant to divide an angle into two congruent angles. All right, well, that's the situation here, where it tells us that ray BD bisects angle ABC. Because I know that, what I know is that angle ABD, its measure has to be equal to the other angle in the bisection, angle CBD. And that makes this pretty easy to work with. Alright, what I'm asking us to do is to find the measure of angle ABC. Angle ABC, of course, being the larger angle. If I know that the measure of angle DBA is 37 degrees. So right here is 37 degrees. Well, let's use a little common sense. If this ray bisects angle ABC, that means that the measure of angle ABC has to be twice as much as the measure of angle ABD or DBA, whichever you want to call it. So the measure of angle ABC is going to be twice 37 degrees, and it's going to be 74 degrees. Great. Let's try another one. Alright, same information. Try to answer this one on your own, then watch me do it. Pause the video, please. Alright, here you see the answer. Should have gotten 64 degrees for the measure of angle DBC. Now, if you notice in the picture, the angle measure that I gave to you, angle CBA or angle ABC, whichever way you want to call it, that was the larger angle in the picture, the 128 degree angle. And then you were trying to find the measure of angle DBC, which is one of the smaller angles right there. And because ray BD bisected angle ABC, that meant that the measure of angle DBC had to be half the measure of angle CBA. The smaller angle was half the measure of the largest angle in the picture. And so simply we just measured 1/2 times 128 degrees, or multiplied 1/2 with 128 degrees and got 64 degrees. We're going to try one more with algebra, then we'll be done with these notes. Now, it's important that you never assume that a ray bisects an angle unless you're given information to lead you to believe that. And in this case, we're told directly that ray BD once again bisects angle ABC. And what we're going to try to do then is we're going to try to find the measure of angle ABD if its measure is 12x plus 11 and the measure of angle DBA. That's the exact same angle, isn't it? Didn't mean angle DBA. What I meant to say was angle DBC right there. If the measure of angle DBC is 4x plus 78 degrees. Okay, now the measures of those two angles have to be equal because of the angle bisector, and so we're simply going to set those equal to one another. 12x plus 11 equals 4x plus 78. Just another way of saying that the measure of angle ABD is equal to the measure of angle DBC. So let's subtract 4x from both sides. That'll give us 8x. 78 minus 11 is going to give us 67. And so we're going to get x is equal to 8 3/8, so 8.375. Alright, then the measure of angle ABD is going to be 12 times 8.375 plus 11, which is equal to 100.5 plus 11, so 111.5 degrees. And if you test with the 4x plus 78, you're going to find that 4 times 8.375 plus 78 is also 111.5. And so we can verify then that these two angles had the same measure and they were congruent to one another. Confirms the angle bisector. Great job today. Hope you took good notes. Hope that you've got some questions to ask, and hope that you're ready in class tomorrow to ask some of those questions and to learn a little bit more and get some practice in. Good job again. We'll see you guys next time.